Hi all, welcome to another math video. And this one will be starting Module 4 and looking at solving quadratic equations. So I've got the learning guide up, but I kind of want to do a crash course on these things first. So let me just walk you through some more general notes, and then we'll get to solving the learning guide questions. Okay, so quadratic equations, that's the focus. So quadratic equations. So first, what is a quadratic equation? That is just a degree 2 polynomial. So what do I mean? I mean a quadratic equation is just something that looks like ax squared plus bx plus c equals 0. So that's the so-called canonical form. So if you move everything to the left side of the equation and then combine like terms, then that is what you will get. It'll look the same kind of way every time. So now let's look at some of the most common ways to solve those things. So the first method is so a lot of people will have taken some sort of algebra class before, and they'll say, oh, I know the quadratic formula, that's the only thing I ever need to know. It's true, it works every time, but it's pretty cumbersome, and you can save yourself time if you know some of the other techniques. And these other techniques are actually how the quadratic formula is found. So the first one is the so-called square root principle. And what this says is if you have an algebraic expression squared and it's equal to just some number, then the next step you can do is you can just take away the square and write the algebraic expression, and that will equal plus or minus the square root of the number. I'm emphasizing this as algebraic expression equal to a number because a lot of people just use this when they have something, say for example, you have x squared equals 16, then you could write this as x equals plus or minus the square root of 16. So we would know that x is equal to plus or minus 4. But this is a much more useful tool than just using it to solve things like x squared. So another example you might encounter would be something like, say we have x squared plus 8x plus 16 equals 7. You might look at that and say, oh my gosh, there's no way I'm going to be able to do that. I have to try some other technique. But if you remember from the last module, we learned how to factor these quadratics, and you'll see pretty quickly that you can factor the left-hand side as x plus 4 times x plus 4, which equals 7. And really, this is an algebraic expression squared. So x plus 4 squared equals 7. And now, because we have an algebraic expression squared, we can apply the square root principle. So this will tell me that x plus 4, we take away the square, it equals plus or minus the square root of 7. And then to get x on its own, we just move 4 to the other side. So it's negative 4 plus or minus the square root of 7. So again, this plus or minus notation, I don't think MyMathLab accepts it. So you would actually want to write both numbers. So this is just shorthand for negative 4 plus the square root of 7 and negative 4 minus the square root of 7. And that pretty much shows the usefulness of the square root principle. So that's technique 1 to solving quadratic equations. So let's look at another technique to solve these things. So technique number 2, I'll say solve by factoring. And the key thing to know when you're solving by factoring is what's called the zero product principle. And what this says is that if you have two algebraic expressions, a times b, and they equal to 0, then either a has to be 0 or b has to be 0. And this is going to be a very useful tool. So let's say we have something like x squared minus x minus 12 equals 0. Well, we know the left side factors. X minus 4 times x plus 3. And what that means is we have two things multiplied together that equal 0. So we can actually break this complicated equation into two separate easy equations. So x minus 4 equals 0, or x plus 3 equals 0. So this tells me that x has to equal 4, or x has to equal negative 3. And we can use that technique to factor these equations. I'm just going to kind of leave it at that right now, because we'll see some more when we go through the learning guide. And then, okay, so technique, I'll call this 3A, because this is the major one toward going toward the quadratic formula. So this is called completing the square. And it kind of teams up with the square root principle to give you a method to solve equations. So maybe we'll do a couple examples all at once. So this completing the square method. Let me give you, we'll try 3 kind of at the same time. So the first example, so all these we'll just try and solve. So let's say we have x squared plus 6x equals 1. And then over here we'll say we have x squared minus 8x equals 3. And then over here we'll do something a little trickier, something like x squared minus 9x equals, I don't know, 5. Okay, so in each of these equations, you can move the thing to the other side, and there's not an obvious way to factor. Also, there's not an obvious way to transform this into a perfect square binomial on the left side. But there is a way to actually do that, and that's going to be kind of the trick for completing the square. There is a number we can add that'll turn this into x plus something squared. And the way you get the number to add to both sides is you look at the coefficient of x. So in this first example, it'll be 6. We'll take half that number and then square it. So half of 6 is 3. 3 squared is 9. So I'm just going to add 9 to both sides. It's an equation, so certainly I can do that. And check it out, we can actually factor this as x plus 3 times x plus 3. So we get x plus 3 squared. That equals 1. That gives us a way to apply the square root property, or the square root principle. What are we going to add in the second one? Well, we take half of negative 8, negative 4. When you square it, you get positive 16. So in this example, we're going to add 16 to both sides. And when this one factors, it factors into x minus 4 times x minus 4. So we get x minus 4 squared equals 19. And then the last one, this one's a little bit trickier because we have negative 9. So negative 9 over 2, let me come up here and just kind of do it in scratch work. Negative 9 over 2, if you square that number, it actually equals positive 81 over 4. So that's stuff from Module 1. Square the top, square the bottom. When you have a number that doesn't divide evenly, and the other one's 6 divided by 2 gave 3, and negative 8 over 2 gave negative 4, you just keep them as fractions. So don't write that as 4.5 or you won't see how to factor. because we're shooting for the exact answer. So here we have 8 squared minus 9x, and we're adding 81 over 4 to both sides. So this equals 5 plus 81 over 4. And a quick trick, you actually don't need to think. These things always factor into a perfect square, so it's going to be x, and then what's the other number going to be inside the square of the binomial? You just look at the number that you squared originally, so this will be x minus 9 over 2. And that worked every time. And over here, negative 4 was the number we squared, and positive 3 was the number we squared. So that's a good trick. And to add these two fractions, we have to get a common denominator, remember. So to do that, 5, we'd have to multiply it by 4 over 4 to add it to 81 over 4. So we have x minus 9 over 2 squared. This will equal 20 over 4 plus 81 over 4. So we get x minus 9 over 2 squared, and that will equal 101 over 4. So let's quickly just solve these for practice with the square root principle. So we'll go through the last line and solve to remember how that works. So the first one over here, let's come back to x plus 3 squared equals 1. So the square root principle says that means x plus 3 equals plus or minus the square root of 1. But really, that's just x plus 3 equals plus or minus 1. So we can move the 3 to the other side. So your two answers will be negative 3 plus 1, which is negative 2, and negative 3 minus 1, which is negative 4. Alright, not too bad. The next one, x minus 4 will equal plus or minus the square root of 19. Then just move the 4 to the other side. So x equals 4 plus or minus the square root of 19. So your two answers are going to be 4 plus root 19 and 4 minus the square root of 19. Alright, the last one, the tricky one, same first step. X minus 9 over 2 is going to equal plus or minus the square root of 101 over 4. And I'm going to write that as plus or minus the square root of 101 over the square root of 4, because we know the square root of 4 is equal to 2. So I can do the square root of 1 over 1 over 2. That way, when I move the 9 to the other side, I actually get a common denominator where I can add these two things up. So I get 9 plus or minus 101 in the numerator, and then just the whole denominator is 2. And so hopefully from that example you can see how you can use completing the square to really get the quadratic formula. So that's what I'm going to call 3b, the quadratic formula. So what this says is the solutions to ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So this is just a plug and chug kind of method. It'll get you to the answer every time, but it's, I don't know, kind of boring in my opinion. I like to stay more active when I solve equations, but let's see how to do this. Okay, so whenever it doesn't factor a square root principle, we're going to have to do something like this. So let's say we have something like 5x squared plus 2x minus 1 equals 0. So to use the quadratic formula, just figure out what your values are. A is 5, B is 2, and c is minus 1. So we know the solutions are going to be of the form x equals negative 2 plus or minus the square root of 2 squared minus 4 times the a value, which is 5, times the c value, which is negative 1, all divided by 2 times 5. So then the rest is just arithmetic simplification. So we get negative 2 plus or minus the square root of 4 plus 20 over 10. So x is equal to negative 2 plus or minus the square root of 24 over 10. And sometimes you'll see the solutions go through some simplifications. In this example, notice that the square root of 24 isn't in simple radical form. But you could enter something like this on MyMathLab and it'll take it completely correct, but the answer it'll show you at the end would be a little more complicated. So I'll show you what they would do just at the very end here. So they would write it instead as negative 2 plus or minus 2 square root 6 over 10. And then they would cancel a factor of 2, so they'd take out a 2, negative 1 plus the square root of 6 over 10, and then they'd cross off this 2 and make this a 5, and on MyMathLab they would tell you the answer is negative 1 plus or minus the square root of 6 over 5. And remember how we went from the square root of 24 to the 2 square root 6. The square root of 24 is really equal to the square root of 4 times the square root of 6, which is equal to 2 square root 6. Okay, so that's it. Let's get started on the learning guide, but first I think I'm going to... So last semester when I was teaching this, some of my students told me that there was a terrible song to the tune of Pop Goes the Weasel to remember this formula. And so now I'm going to subject you to that, and then we'll go through the learning guide. Actually, I think you're going to come away unscathed and not have to listen to the video, because the way I've got this set up, it can only record the sound from my microphone and not from the actual computer. But if you really want to see it in all its glory, just go to YouTube and type in Pop Goes the Weasel Quadratic Formula and it'll pop right up. Okay, so back to the learning guide. Now that we know how to do all these quadratic equations, let's go through them. It should be pretty quick now. So the first one, we got 3x squared plus 12x equals 0. So we have a common factor of 3x we can take out. We'll end up with x plus 4 equals 0. So we have either 3x equals 0 or x plus 4 equals 0. Okay, the only thing that can multiply with 3 and make 0 is 0 itself. So x is 0 or x is negative 4. Alright, let's scroll down and look at the next one. So the first thing here, it's probably going to factor. We just need to move everything on the other side. So subtract 8x, add 15. You'll end up with x squared minus 8x plus 15 equals 0. Just remember, when you move something to the other side, you got to change its sign. Then this factors into x minus 3, x minus 5. We do the square root principle again. We get x equals 3 or x equals 5. Alright, pretty straightforward on those. Nothing exciting. Square root principle. This will be pretty straightforward as well. Start off by subtracting 1 on each side, so we get 5x squared equals 51 minus 1 is 50, and divide by 5. So we get x squared equals 10. Then the square root principle tells me that x is equal to plus or minus the square root of 10. Alright, the next one, okay, so here's the deal. When you take, sometimes quadratic formulas will have, you'll end up with the square root of a negative. And in this class, we're only focusing on basically real valued solutions. So on the homework I took all those out, but I think one of them kind of slipped through the cracks. So I'll do this example and kind of show you what I mean. So this is going to be a square root principle again. So start by adding 5. 2x squared equals negative 50. Divide by 2. X squared equals negative 25. And then we do the square root principle. X equals plus or minus the square root of minus 25. Okay, so when you get the square root of a negative, these are actually complex numbers. They do exist, but they're a lot of things can be done without them. But I think there is one that slipped through the cracks on the homework. I tried to make sure they were all out of there, but I think there's one that has an I value. And the thing is, whenever you have the square root of a negative, you can just turn it into the square root of negative 1 and the square root of 25. And then the square root of negative 1 just turns into I. So this is just going to be x equals plus or minus I. And then the square root of 25 is 5. So normally they write it number first, letter second. So this would be plus or minus 5i. And then on my math lab, you just type it in as x equals 5i, comma, negative 5i. Excuse me. But nothing really terrible there. You just need to turn the square root of negative 1 into an I. I apologize that square root of negative 1 up here kind of looks like a 7, but please note that's a negative 1. Oh my gosh, I did something terrible. Alright, next one. A pretty common one we've seen. Just start by dividing by 3. So we get x minus 4 squared equals 5. Then do the square root principle. X minus 4 is plus or minus the square root of 5. So x is equal to 4 plus or minus the square root of 5. Okay. 3a is a pretty straightforward one. It says, what term should be added to the binomial x squared minus 10x so that it becomes a perfect square trinomial? Write and factor the trinomial. We know that. We take half of negative 10 and we square it. So we get positive 25. Negative 5 squared is positive 25. So you would get x squared minus 10x. And then if this were an equation, you'd add it to both sides. But we end up getting this, which is x minus 5 squared. So we're good at that. We know how that works. If not, go back to earlier in the video when we talked about that. Alright, so solve by completing the square. That 11, let's move it to the other side. So we got x squared plus 6x equals positive 11. Now we think about what to add. We're going to add half of 6 squared. So we're going to need to add 9. So x squared plus 6x plus 9 is going to equal 11 plus 9. So we get x plus 3 squared equals 20. So x plus 3 is plus or minus the square root of 20. So x is negative 3 plus or minus the square root of 20. Alright, next one is kind of interesting, completing the square. Again, let's just move that 2 to the other side. Here's the trick with this one, though. Normally, the number we have is always regular x squared. So what do we do to fix that? Well, we got to divide both sides by 3. So when you divide both sides by 3, remember it's a common denominator on the left. So we can really write this as x squared minus 2/3 x equals 2/3. Now we need to figure out what to add, which is a little tricky, but not so terrible. Half times 2/3 is 2 over 6. So that's the number we need to square. But 2 over 6 is really 1 over 3. So this is 1/3 squared. So we end up with a ninth. We need to add a ninth to both sides. So x squared minus 2/3 x plus 1 over 9 equals 2 over 3 plus 1 over 9. Okay. This is actually one of the ones where I would say the initial equation, I do the quadratic formula, just because this is a little complicated for completing the square, but what are you going to do? So we end up with x minus 1/3. Remember, that's the special number we squared. We square it. 2/3 is really 6 over 9. So if you don't remember, I'll do that. I'm going to come over here and kind of butt into the solved example and just multiply that by 3 over 3. You see it's 6 over 9. So when you add 2/3 and 1/9, you will get 7 over 9. So now we're going to get x minus 1/3 is plus or minus the square root of 7 over 9. So we get x equals 1/3 plus or minus. I'm going to write this, remember, square root of top over square root of the bottom. So it's square root of 7 on top, and then the bottom is really just 3. So we can write that as a single fraction. X equals 1 plus or minus square root of 7 just over 3. And that's it. Great answer. Good job, team. All right, solve using the quadratic formula. So here a is equal to 3, b is equal to minus 3, c is equal to minus 4. So if you don't remember the formula, just check it out over here, and we'll go about our business. So the opposite of minus 3 is positive 3. A lot of people get confused by that, but two negatives, they make a positive in math. In real life, though, they say two wrongs don't make a right, so I don't know. Philosophically decide for yourselves. Negative 3 squared minus 4 times 3 times negative 4. Square roots over everything. Sometimes you don't make it long enough. Divided by 2 times 3. And then the rest is just arithmetic. 3 plus or minus square root of 9. 16 times 3, we're adding 48 over 6. So we end up with x equals 3 plus or minus the square root of 57 over 6. And then we can't really do any simplification there because 57 is a prime, so it's already in simple radical form. Coffee tastes good. Another one with a quadratic formula. I'm going to skip this one, though, and that's just because we're going to end up with a square root of a negative. But go ahead and try it yourself. I can tell because I know that b squared is going to be 36 and 4ac is going to be negative 40. So just by looking at b squared minus 4ac, you can tell whether or not you're going to have a quadratic. So I will mention that right here. So that number b squared minus 4ac is called the discriminant. And if b squared minus 4ac equals 0, you get one real solution. If b squared minus 4ac is positive, you get two real solutions. And if b squared minus 4ac is negative, you get two complex solutions, or two imaginary numbers. So in this case, a is 1, b is minus 6, and c is 10. So b squared minus 4ac is 36 minus 40, which is negative 4. So we know we'll have two complex solutions. And I won't be testing you on any complex solutions. I meant to take them out of the homework, but one slipped through. But it's nothing like this. So just move forward. Okay, all right, so compute the discriminant and the number of solutions. Next two, I jumped the gun. These are all very similar. So we'll just do the first one and kind of move on. You can see how to do that. So b squared minus 4ac here is equal to negative 2 squared minus 4 times 1 times 1. We end up with 0. So that tells us that we have one real solution. Next two we can probably do pretty quickly in our head. So b squared here is going to be 16 minus 4 times 1 times negative 5. So we'll get 16 plus 20, So we know we're going to get 2 real solutions because it's a positive number, whatever it is. Next one, 4 times a times c is going to be a big number, something like negative 48, and b squared is just 4, so that should give you 2 complex solutions. Let's look at question 6. What is the most efficient method for solving a quadratic equation of the form u squared equals d, or use a first degree polynomial? Well, we know that's the square root principle. That's the ones we've done before. Remember we said for any algebraic expression, if you have it squared and it equals a number, then you just do plus or minus that number. Okay, last one, word problem. Number of fatal crashes per 100 million miles driven, F for drivers of age X, can be modeled by the formula with some kind of ugly numbers. What age groups are expected to be in the 3 crashes per 100 miles driven? Okay, that's kind of funny wording. Let's see what they're talking about. Do we have to solve anything or just plug something in? Okay, let's see. Number of fatal crashes per miles driven is F. Okay, so they're saying 3 fatal crashes per 100 million miles. So they're giving us a number for F, and they want us to solve for X. So that's what's going on. So F equals 3. So basically plug in F equals 3 and solve. So we have 3 equals 0.013x squared minus 1.19x plus 28.24. Alright, so then subtract 3 on both sides, and we'll get 0 equals 0.013x squared minus 1.19x, and then when you take away 3, you'll get 25.24. Alright, so you can do the quadratic formula from here to solve. Or else, I don't know, sometimes it's easier to work if you don't have decimals. So you could get rid of decimals by multiplying both sides by 100. Oh no, because it's 0.03. Ugh. Alright, so it's just going to be an ugly number. So let's just bite the bullet and go to work. A equals 0.013, B is negative 1.19, and C is 25.24. So here X is going to be 1.19 plus or minus the square root of negative 1.19 squared minus 4 times 0.013 times 25.24. That's all under the square root. And then we're going to divide this by 2 times 0.013. Okay. Alright, so let's see. Let's try and simplify this number a bit. So we get 1.19 plus or minus. Alright, let's do this number somewhere. I got a calculator on this computer. It's probably not as good as the Google calculator, but let's see. So 1.19 times 1.19 gives me 1.19 squared. So I'm going to do the square root. Oh no, and now I've forgotten the number because I can't have it on the screen the same time I'm using the calculator. Maybe I can make this slightly smaller. Yeah, let's try this nonsense. Alright, so what do we get? You see 1.4161. And then what's the other number? We've got minus. Alright, let's figure out the other number first. 4 times 1. Clear. 4 times 0.013 times 25.24 gives me 1.31248. And then we come over here, and when you multiply the bottom by 2, that'll just double those. So 2, 6. Alright, so x is going to equal what? 1.19 plus or minus, and let's try and compute the square root. So what are we going to do? We're going to do 1.4161 minus 1.31248. It gives us this number, 0.10362. So we need to figure out the square root of this. So I've got a square root button here, so I hit it, and I get 0.3219. So plus or minus 0.3219, all divided by 0.026. So we can compute both those numbers separately. So let's do 1.19 plus 0.3219 equals that, divided by 0.026, get 58.15. Okay, and then where we want to do the other one. So I think I subtracted first, but I can't remember. So I'm going to add and hope that's what I didn't do. 0.3219 equals this number divided by 0.026. Nope, I did the plus first, so I need to subtract 1.19 minus 0.3219 equals this divided by 0.026. Okay, so the other number is 33.39 if you round to the hundredth. 33.39. So those are your two answers. I think it asked for an age range, so I'm guessing that our answer here is going to be yeah, it says what age groups are expected to be in the crashes. So our two age groups are 58-year-olds and 33-year-olds, basically. Yeah, so down here, 33-year-olds and 58-year-olds. So we did it right. Okay, so this has been a pretty long lecture. So I think I'm gonna end this one here, and then we'll come back and start 1.6 and 1.7. Those aren't quite as long, but just kind of developing all the machinery for the quadratics made this a little bit longer video. But okay, take care and have a great one. Bye.